Hi guys, this is the fourth lecture for the cardiovascular system, and at this point you've learned about the major blood vessels, how they work, and how they deliver oxygenated blood to all the parts of your body and then back again to the heart. Today is about the special circulation, so we're learning about the organs, the blood delivery to the organs that are most essential to your survival, which means your brain, as well as the liver and the digestive organs. We'll also be talking about fetal circulation as well. So that's circulation through a growing fetus in a mother's womb when that fetus does not have functional lungs of its own to oxygenate its blood. Damage to these organs can result in severe bleeding that may cause permanent damage or death. That's especially relevant because a lot of the times if people have untreated cardiovascular disease, they can have complications from damage to these essential organs, like, for example, a stroke in the brain. The cerebral blood vessels, that's what we're starting with. These are the ones you need to know. And if you look at this image, the way to think about it is imagine that you have your sheep brain that you were dissecting, but now you flipped it over on your dissecting tray so that the top of the brain is now on the tray and the bottom of the brain is up and facing you. So this is what we call the ventral view. And here you can see that this is the pons. Here's the cerebellum. Here are the temporal lobes. Here is the inferior part of the frontal lobe, and then the parietal lobe is away from you, out of view. The easiest way to memorize the major blood vessels that service the brain is to watch this video. And I did also post it in Canvas separately, so I would recommend that you watch that so you can hear the narration that goes along with it. I'm also going to be narrating it here since I had to mute my mic in order to do this presentation. So you guys know that the heart pumps oxygenated blood through the aorta, which is right here. And then the aorta sends major blood vessels up your neck to your head. And this is the anterior view, by the way. So this person is staring straight at you. And the anterior blood vessels run up the sides of your neck. They're called the right and left carotid arteries. And then once they reach your brain, they branch off into what we call the anterior and middle cerebral arteries, while the back blood vessels run along the back of your neck, along the vertebrae. They're called the right and left vertebral arteries, and they fuse to form the basilar artery, which then splits into the posterior cerebral arteries. At this point, you've been looking at the anterior view, but now we're going to turn it sideways. And here you have the eyeballs, and here would be your nose, and we're going to start with this white blood vessel right here. So this is the carotid artery. Remember, you have one that goes up the right side and the left side of your neck. And then when it reaches the brain, it splits into the anterior cerebral artery that feeds the middle and front of your brain, as well as the middle cerebral artery that feeds the lateral parts of your brain. And then back here you had the vertebral arteries along the backside of your neck that fuse into the basilar artery, which then later becomes the posterior cerebral artery to feed the back of your head. Now, what you don't want is for there to be some sort of a blood clot that cuts off blood to a portion of your brain, and that could end up causing death. And so to prevent that from happening, we have this circle of Willis. Yeah, there we go. We have this circle of Willis right here. So it's this connecting artery right here that ensures that, let's say we have, I don't know, like a blood clot right here. That would suck because that would mean that you would have no blood going to the entire backside of your brain. Fortunately for you, this communicating artery right here ensures that if something were to go wrong, back here, let's say, that blood coming up this side of your brain, some of it could be shunted through here to then feed the parts of your brain that normally would have been cut off from their blood and would have had to die. And so this is kind of like a backup measure that your body has to ensure that its most essential organ, which is your brain, is able to function even when the blood vessels themselves may not be functioning. So going back to that ventral view that we had before, here are those major arteries again. We have, in the backside, we have the left and right vertebral arteries right here at the bottom, fusing into the basilar artery right here, which then branches off into the posterior cerebral artery this way, and then the posterior cerebral artery going that way. From the front, you've got these cut-off blood vessels, but just imagine that they're extended and running all the way down the front of your and the sides of your neck. So that would be the carotid arteries. You can see that word here, carotid artery, right? And then the carotid arteries branch off into the middle cerebral artery right here, as well as the anterior cerebral artery right there. And last of all, you have this communicating artery here and here. And because they're there, you have almost like a circular pattern right in the middle of your brain. And we call this the circle of Willis. And that's to ensure that blood can flow to the parts of the brain, even if you have a blockage of blood through one of the major blood vessels that would otherwise have to supply it. At this point, if you wanted to pause the narration so that you could just study this image some more, and you can follow along with where are the labels for each of these major arteries: the vertebral arteries, the basilar artery, the posterior cerebral arteries, the carotid arteries, the middle cerebral artery, the anterior cerebral artery, and the circle of Willis. And when you're ready, you can unpause the video and you can move on to the digestive system. Okay, next we're going to talk about the digestive blood vessels, and here are the blood vessels that you need to know. I'm going to point out the renal vein right now because it's not going to appear in our video or in, it doesn't even appear in this image, but the word renal means kidney, and the kidneys have not been pictured here just because they would clutter up the image and make it harder to read. But the renal vein, once again, brings blood from the kidneys back to the heart. Over here, another two that I want to point out to you right now is the hepatic portal veins, and the hepatic portal vein and the hepatic vein. Those two sound really similar, and it's easy to mix them up. So here's the way that I would talk about it. The word hepatic means liver. There's your liver right there. So if we were doing the rat dissection, what you would see as soon as you opened up the belly of the rat, the first thing that you would see is this gigantic liver. So hepatic means liver. You have the portal vein, which transports blood to the liver. There it is. And you have the hepatic vein, which transports blood from the liver back to the inferior vena cava. Okay, so here's a video that you can watch, and you can also pause the video whenever you need to read the text on the side. There's also a narrated version of this video in Canvas, but the narrated version is just a narrator reading the text off to the side. I'm going to provide my own narration, which is going to differ a little bit from what you see here. Okay, so let's start with, you know that anytime you have food or drink entering your body from your mouth, that's the main time that your blood can become contaminated with things that can pose a real threat to your health. And so there's the esophagus. It's just the tunnel from the mouth straight into the stomach. And then from there, all of that stuff will go into the small intestine here, and then into the large intestine. And all of these organs are surrounded by blood vessels because, first of all, they have to feed these organs with oxygen so that, they can stay alive. And then second of all, they have to receive nutrients from your food, which then go into the blood, which then can be delivered to all of the parts of the body. But you want to make sure that you're only delivering nutrients from your food, not toxins. Because what if you had bacteria in the food that you ate? Or what if you were drinking alcohol or something that could really be harmful to the health of your organs? That's the reason why you need the liver. So before the blood, the deoxygenated blood from all of these digestive organs gets returned to the heart, it must pass through the liver. The liver cleans the blood and then returns clean blood to the heart. And then the whole cycle repeats itself. So to give you some perspective, this is the stomach right here. Behind it is the spleen, but also the pancreas. So I think this is actually the outer part of the pancreas, and then it wraps around this way. Or it could be the spleen. Here you have the gallbladder. Then once again, here is the small intestine, and here is the large intestine. So right now what's happening is deoxygenated blood is draining from the stomach through what we call the gastric vein, because gastric means stomach, and it's draining from the pancreas and spleen through what we call the splenic vein. So here's the splenic vein. And then over here, blood is draining from the intestines through into this vein, which we call the mesenteric vein. And then the splenic vein and the mesenteric vein join together to form the hepatic portal vein, which takes the blood to the liver. So here we go again. You've got the gastric vein from your stomach and the splenic vein from your spleen. And then these two are going to feed blood into the splenic vein. Well, at the same time, blood from your intestines drains into the mesenteric vein here, the superior mesenteric vein. And then those veins, splenic and mesenteric, drain into the portal vein. This vein is also called the hepatic portal vein because remember the word hepatic means liver. So now you've got this potentially toxin-filled blood or potentially dirty blood based on whatever it is that you might have put into your body. That's now going to be delivered to the liver through the portal vein. Once it does, that blood is going to fill all of these capillaries that run throughout all the lobes of the liver. And the purpose of that is to provide lots of surface area so that toxins could be filtered out of the blood and that only good things can be left in the blood by the time they get here, the hepatic vein. So once again, this is the hepatic portal vein. It's delivering potentially dirty blood to the liver. And then here is the hepatic vein, and it's delivering clean blood into the inferior vena cava, right there. And the inferior vena cava will also receive deoxygenated blood that came from your lower body, so like your legs and stuff like that, which you'll see here. So all of this deoxygenated blood from your lower body and from your digestive organs is now drained into your inferior vena cava. And here you can see those again. This image is a little harder to interpret, but once again, this is your stomach here, right there. Behind it in those dotted lines is your pancreas. I know it's kind of hard to see. Here's your spleen. And so deoxygenated blood from your stomach, pancreas, and spleen are going to drain into the splenic vein here. While at the same time, blood from your intestines are going to drain into the mesenteric vein. And then those two veins join up behind all these organs into this vein right here. That's the hepatic portal vein. Remember, at this point, we should assume the blood is dirty because it might have been exposed to toxins or bacteria from your food or your drink. The liver will then clean that blood up and return that blood through these veins there, which fuse to form the hepatic vein, which then drain into the inferior vena cava.